This screencast is about how to find the slope of a line. If you have 2 points, x1, y1, and x2, y2, then the slope of the line between those 2 points, we use the letter m to show the slope, and then we're going to subtract the y coordinates, put that on top of a fraction, and subtract the x coordinates and put them on the bottom of a fraction. Now the order of these 2 points is not really important, but you do have to stay consistent. So we want to use subscripts like this just to show which one is which. Another important thing that I want you to pay attention to is this statement here. x1 cannot equal x2. If that's true, then we'd be subtracting the same number in the denominator and you'd divide by 0. If that's the case, we have an undefined slope, just like you'd have an undefined number. All right, here's the first example. I went ahead and put the slope formula here just for reference. All right, so we have the points 2, 1, and 4, 6. Let me go ahead and label those points. You'll probably want to do the same thing. That's x1, y1, x2, and y2. For the slope formula, I'll go ahead and write m equals y2 minus y1 all over x2 minus x1. After simplifying, we find out that the slope is 5/2. Let's go ahead and take a look at this on the graph. There's the point 2, 1. And here's the point 4, 6. If you notice, to get from one point to the next, I'm going to go up 5 units and over 2 units. That's because slope is all about rise over run. So up 1, 2, 3, 4, 5, and then over 2 units to get there. It's almost like a stair step in order to get to the next point. Notice how this slope is positive, which means the line that would actually go through these 2 points is rising to the right. In this example, the points are 3, 2, and negative 4, 5. So I'll label this one also x1, y1, and x2, y2. So the slope will be 5 minus 2 all over negative 4 minus 3. 3 over negative 7. I like to keep that negative on the top, so let me change this to negative 3/7. Here are the points that we just talked about, 3, 2, and here's the point negative 4, 5. You notice a big difference about this line. If you're reading it like a book from left to right, this one actually falls as you move to the right. That's because of this negative sign here. So lines that have a negative slope will actually fall from left to right. Let's try a new one. Negative 4, negative 3, negative 1, negative 3. y2 minus y1, I'm going to be really careful because those double negatives, all over x2 minus x1. I'm even using parentheses here so that I don't get mixed up. This turns into negative 3 plus 3, which is 0. In the denominator, negative 1 plus 4, which is 3. Now 0 divided by any number is 0. So I have a slope of 0. Let's see what that looks like. Here's my first point. Here's my second point. So to have no slope just tells you that the line, or to have a 0 slope tells you that the line is horizontal. It's not going up or down at all, just completely flat. Now, because I was able to draw these lines, you should see that I can actually create a unique line connecting those dots. For the next 2 examples, we're going to go ahead and look at lines, but they're only going to give you 1 point on the line. Now, we can't really connect a dot if you only have 1. So the other piece of information that will be provided is the slope. So I'm going to first of all plot the point 0, negative 2, because the line itself goes through this dot. The slope of 1/3 is telling me how to get to the next point. Remember, slopes are ratios, they're fractions. So the top number is going to tell me my rise, and the bottom number will tell me my run. This is telling me it's a rise of 1, or in other words, up 1, and it's a run of 3, or over 3. So from this dot, I'm going to count up 1 unit, and then over 3 units. 1, 2, 3. And put another dot there. I'm going to continue to do that with the next one. I'm going to count up 1, over 3, and put another dot. That's enough now to connect the dots. It's a unique line, meaning there's only one correct answer. Let's look at one more like that. In this one, the starting point is the point 1, 3, right here. It has a slope of -2. Now, slopes are ratios, or fractions, so I'm going to have to change this into a fraction. Think about how you could rewrite -2 as a fraction. That's right, -2 over 1. In terms of slope, I'm going to be going down 2 over 1. Down 2 over 1. So let me count. From this point, down 2 over 1, and put a dot. Do it again. From this dot, down 2 over 1. Again, down 2 over 1. There's another one. Down 2 over 1. You can continue this as long as you need to get a good picture of the graph. There it is. So slope is really important. It's going to show us exactly what the steepness of the line is. We can actually graph a line if you have one point and the slope.